The changing climate is a story about the future of our ocean.
We are concerned as ocean scientists about the health of the resources we depend upon from the ocean.
Climate change is going to make us let go of all of these ecosystems.
How long does it take to prepare for sea level rise? How long does it take to prepare for ocean acidification?
Climate change impacts not only the organisms that live in the ocean, but ultimately the people that depend on the ocean.
Over 1 billion people on the planet already derive a really important part of their income from the ocean.
15% perhaps of all the protein consumed on Earth is ocean protein.
Wild food is important not just to global commerce, but to hundreds of millions of people who use it for subsistence.
It would be nuts not to take into account the possibility of a tipping point that produces a dramatic response that hurts a lot of people.
We need a sea change, if you will, in public opinion to get behind the idea that we can attack this problem and find solutions that will maximize the benefits we can provide for our future generations. In the next 100 years, we expect larger, long-term changes in ocean conditions that will affect the very resources we depend upon.
On the sea level rise side, the key there for me is to understand the two big ice sheets. The big kahunas of sea level rise are the Greenland ice sheet and Antarctica. The vulnerable ice in both of those locations could contribute up to 6 meters of sea level rise. We're doing our part understanding the processes and what's happening now so that we have a better ability to predict what might happen in the next 20 or 30 years.
One of the things that we'll be watching for are changes through our research tagging programs of where animals are going and how they're reacting to these changes.
All the animals we see out here are being bathed with basically the same water. Abalone populations are being used as a sort of a model species. We would like to understand how changes in ocean conditions that are related to climate warming are affecting an important local species for our local economy. Low oxygen and more acidity can be stressful.
We've had events of upwelling low oxygen water, which kills everything on the bottom of the ocean. We also took a look at the potential for runoff from storm sewers and wastewater treatment plants to accentuate this decline in oxygen.
What's the role for conservation biologists? Our role is actually to save as much as possible so that by 2100 there are still healthy parts of the ocean that can seed the regrowth of the rest of it.
The natural system is a more resilient system. This is a time when we can actually think about what we want the future to be and to build a better world together.
Now, rebuilding the ocean isn't just a theory. We know how to do it. We've seen it happen. This is a really good example. I'm standing in front of Monterey Bay. This was the center of one of the biggest fishery and canning industries in the world. The pollution from the canneries and the air in the water was so severe, the overfishing was so severe, but it got better. It came about because of the passion of people to create a better local ecosystem. It came about because of protections for clean air and clean water and marine mammals and birds, and even fisheries regulations that allow fishing and fishermen to survive together along with fish populations in the ocean.
The recovery of the kelp forest and the recovery of the sardine fishery has really meant a difference for what we can do here in Monterey to enjoy the ocean. One of the things we're worried about is what happens under climate change to this amazing recovery story.
So there are lots of things that can be done at the local level to reduce the impacts of globally driven climate change issues that we see.
We can reduce pollution locally, we can reduce overfishing locally, we can reduce runoff locally, we can reduce habitat destruction locally.
And it will make the coastal zone more healthy and more resistant to the big forcing that might be coming from climate change.
And when we do those things, the local marine environment comes back to life in ways that really harnesses the power and the productivity of the ocean to rebuild ecosystems.
A number of the research institutions here around the Monterey Bay are actually watching to see how resilient the system is to climate change and what we might learn for how to protect it.
I am thrilled to be able to be a part of an effort by the research community across the world to try and understand marine ecosystems.
It's very interdisciplinary.
I love working with leaders and managers,
engineers and oceanographers and ecologists and lawyers and policymakers and economists
to help communicate the science.
I find that exciting and challenging.
There are many scientists interested in helping them understand what's really happening, what's the trajectory of change.
It will take a huge effort of the financial part of our society, the political part of our society to make that change happen. But it's incredibly important that it happens.
You need to invest now to mitigate risk and financial costs.
Climate change and the oceans are really tied together. The oceans and people are tied together. And you can't really face the future of climate change without including the oceans in the discussion, the equation, and the solution.
The promise for the future is that we break through and we're able to bring all the ways of knowing about the oceans to solutions that work.